2020 Connect event. We are here again live in the Sintratec headquarters in Bruck, Switzerland. We are here in the Sintratec Experience Center. And first of all, me and the entire Sintratec team would like to address a big thank you for all of the people who watched the first day yesterday. It was a fantastic, interactive, I think, event. We had a lot of questions that we've been able to answer, hopefully to your satisfaction. And today we are going to have a second fantastic live program for you. First of all, we will have live sessions for print preparation. We will have live sessions on laser sintering live, and we will have live sessions of depowdering Sintratec PA12 parts. The main theme of this day is mobility. So between the live sessions, we will have two fantastic customer talks. The first one with our dear Sintratec customer, ETHEC City. This is a project which is in lead by Mr. Tobias Oesch. Hello, Tobias. And Mr. Tobias Oesch is printing or using our technology to create the e-motorbikes of the future. So basically what you will see is a nice technology talk about these casings that are assembled on the e-motorbike of ETHEC City. Secondly, I'm very proud to have one of the leading industrial designers with us today, Mr. Stephan Henrich, our mastermind and genius in terms of SLS 3D printing design. Mr. Stephan Henrich was so kind to give us an insight into one of these fantastic projects. What you see here is a compliant mechanism. And this compliant mechanism we are going to print live today. We are going to depowder it live today. And if you stay tuned until the special event, which is the last event of today, you will see how I will assemble this compliant mechanism, which is basically a bottle holder on my bicycle, and I will drive home like Lucky Luke into the sunset. Good. So I think we again created a thrilling project for you. Please use the chance to interact with us in the chat function. First of all, as always, I already stated that this place, the Sintratec Experience Center, is usually packed. Packed with Sintratec customers, packed with Sintratec visitors, and according to COVID-19, it's no longer the case at this moment. But I would like to introduce you to a small part of the fantastic Sintratec team who made this event possible for you today. So we have here our lovely Vanessa. Vanessa is taking care of the chat function in the YouTube chat. So if you would like to ask a question, Vanessa will be the person who will ask this question for us, and we are going to answer it for you. We have on this side Ramona. Ramona is our marketing manager who has organized everything around the event. Behind Ramona we have Pascal. Pascal, who is today supporting me in some things. He's a member of the sales consulting team.
Formnext Connect, right? They are on that platform too right now.
Exactly. We are all on Formnext Connect. So link with us, chat with us, and we will have a fantastic time together. Good. So this was the introduction. Let me accompany you now a bit deeper into the Experience Center. So what you see basically here are, of course, the most important things like customer use cases from Sintratec customers. A big thank you for all of those who participated, and a hello from Sintratec Bruck in Switzerland. We will have the Sintratec history with us. So these have been the systems that we started with, still the world's first and only and never copied selective laser sintering assembly system, the Sintratec kit. We had the Sintratec S1. You see a few peripherals as well, which I'm going to relate later. And of course, the Sintratec S2 starter cell. We are going to do all of these live presentations on a Sintratec S2 starter cell, and let me accompany you now, because in the back of the Experience Center we have a small amount of our 3D print service printers, which we are basically operating here together with customers to make sure that we can do the best possible hands-on training and to give everybody a deep technology onboarding possibility. Good. So one of our service heroes was here yesterday with us as well. Mr. Dario Arcangeli is basically a service engineer of Sintratec who is going to supporting me today. Dario, how are you today?
All fine, thanks.
Good. So wave the hands, let's do a good show. And here in the back we have our 3D print service plant manager. This is Thomas. Thomas, say hello. And in the corner over there, we will have our fantastic Alessandro, who is part of the content generation team and is basically taking care that all of the videos are going to be put into the quality as you can see it. And these do basically the cutting as well and all the things that are related to this event. Good, so let's start with the first session. Print preparation on a selective laser sintering system, particularly here on the Sintratec S2 starter cell. So Thomas, is it okay if we drop by? Good. The part which is colored in blue or basically in petrol is, so the big one, would you like to show this one? This is the compliant mechanism of Mr. Stephan Henrich that we are printing live today. And in addition, of course, because we would like to use the printer economically, we will print these gliders or sliders, or how do we call them? I think it's sliders. These are basically some parts, multiple parts on the Sintratec S2 starter cell system we print with our own machines. Because we are absolutely, first of all, technology enthusiasts, and secondly, we believe in the quality and the power of the Sintratec PA12 parts.
And this is show us later on the machine, right?
Yes, I will show you later on the machine where these gliders are basically placed and how we usually use them. And yeah, so Thomas is basically preparing a print job now. As you can see, one step zurück. He goes a step back. He has placed multiple of these small sliders, and besides he have this compliant mechanism bottle holder. And basically this is all you need to do. So you import your STL file into the Sintratec Central software. Important is, I think, that Sintratec Central is the house-owned software of Sintratec Switzerland. So this was developed and programmed by our fantastic software engineers. Hello to the team. And yeah, so if you place the parts, there's nothing more to do than generate the print file. So Thomas.
Can I ask something?
Sure.
Why, can you maybe repeat again why you pack it so densely? What's the idea behind that?
Well, basically, you like to use this Sintratec S2 starter cell on a very economical, sensible basis. So we place as multiple parts as possible in one print room or print cylinder to make sure that we can use this time for heat up, printing, and cooling down very economically. Yeah. So that's it basically. And then you have the chance to pre-check the quality of your parts as well, because sometimes STL files can be corrupt, or sometimes the objects are not closed, the shells are open. And here we can cross-check this one, and later on there's nothing more you have to do than to click on the button, generate print file, and then it goes basically into the Sintratec S2 starter cell. Good. So again, you see Sintratec Central on the desktop, our house-owned Sintratec software programmed by our Swiss high-quality R&D and software engineers. Thank you, Thomas, for your time.
Thank you.
And I think now we go straight and live to do the print preparation, or the second part of the print preparation. We will load the system now live. So what you see here is the Sintratec material core unit. Maybe you can show this here as well. So the Sintratec S2 basically is a fantastic semi-automatic high-tech system which contains 3 high-tech machines. So all of these machines are built and assembled in Switzerland. This is a very important point for us. We stand for quality, and the production is here in Switzerland, so we have full control of it. Good. So we have this material core unit where usually or always we load the print job. This material core unit is already placed here below this material handling station. So again, we have a material core unit and a material handling station. And Dario, our service engineer, is now preparing this print job by filling the powder into these containers. For this, we are using Sintratec PA12 print ready material. I will later on explain you why it's called print ready. And basically, we are going to fill these 2 containers. And for all of the people who had the question yesterday, I'm going to repeat it. Is the process powdery and messy? It's not if you take care about how you load the machine. We have an 8-zone high-tech ventilation system here, which is sucking the powder away from you. And we have an anti-static vacuum cleaning system, which is basically supporting and bringing the powder away, that it's not going to be put outside. Good, so Dario, we will now step a bit back because he's activating the vacuum cleaning system. This is just a bit noisy, but you can of course hear it in the microphone, and this is the reason why I'm stepping back. Good, so Dario, can you explain us what you are doing? So basically on this 4K camera system, software shows you step by step what you have to do, that you have a fully guided process so that you cannot do any mistake. Okay, Dario, please. So we are choosing the print file, we are choosing the material, it automatically indicates the height of the print. And the powder containers are moving down then to the exact size or amount of powder that you need. Good. Yes, important step. Safety masks, gloves. Good, so now the coater is starting to get his accurate position. And then you can use this bowl. And fill in the Sintratec PA print-ready powder. You see it's easy to handle, it's easy to operate. You see as well that the ventilation system is sucking the powder into the gaskets. Dario, is there anything more you would like to mention now?
For filling up, the important steps will all be shown in the screen.
Good. So you see we are filling up both powder containers because the coater mechanism is the moving from the left to the right side and is creating the top equal surface that you need to start the print. This is an important part of the process. And again, you can see that the powder is basically not coming out. It's not a room clean solution, that it's not. But basically, if you operate it on a daily basis, you will see that it's pretty easy to do that. Good, so it's important as well that you fill powder on the middle part of the cylinder as well. Correct, Dario? Good, so now you can already go to the next step. The system is asking you, did you choose, of course, the right material? And now a very important point. Can I have this tool? Yesterday there was a question raised about how we call this tool. And Janne, can you support me, please?
Spatula.
It's a spatula. Right. So for the person who asked this question, this is a spatula. I've mispronounced this. Please excuse me for that. And this spatula is an important tool to make sure that we can make the powder a bit more dense, because you will see that it's not fluid, it's of course powder, but it moves pretty slightly, a bit like water. Is that correct, Dario? And with this movement, the powder is shaking down and gets its own density in terms of that the coater can be absolutely fantastically do the equal surface on the top layer. So again, this spatula is an important tool, and you see it's all semi-automatic. And if the process is done, you have a leverage difference here, or level distance, which we need to fill up again to make sure that everything goes smoothly. Good, so Dario, is the cleaning solution loud?
No, it's okay, you don't need ear protection.
Okay, so I was asking Dario, our service engineer, if the cleaning solution, so this vacuum cleaning system is loud. So you do not need any kind of ear protection for this. Maybe because of the microphone you hear it a bit more noisy or louder, but it's basically not louder than your own self vacuum cleaner that you are using at home. Good. So the process is done, and now you will see that the coater is starting to move, and you see that the surface is not equal now. So here it's an important step as well, that you refill a bit of powder on the layer, that you get this equality that you need. And you see now with the next 2, 3, 4, 5 movements, you see how fantastically smooth this surface becomes now. Is there anything else we should be aware of, Dario?
Yeah, the most important is that the center area is covered by powder. that it's smooth, that you have no lines in it from damages on the counter or dirt inside the powder.
Correct, yes. Yes, so Dario just stated that it's very important that the coater blade, there is a blade below, is cleaned after each printing process, correct? Yep. Because sometimes some small PA12 particles can stick there, but this is all written in the manual. It's a high-tech machine, so you have to carefully follow the manual, but then it's easy to operate. Good. Welkom afstellen. Good, so then we are sucking away a bit of press powder that is basically not in the print area. Then we can deactivate the vacuum cleaning solution. And you see, the preparation of the print job is already finished, it's done. Dario, is there anything more you would like to add? I mean, for the audience, we did it now very slowly to give you the chance to see the interactions. Usually we do it about twice the speed because we operate the systems on a daily basis. And now what we can do is it okay if I do it? Yeah. Okay. Now we remove the material core unit easily from the material handling station. So these two systems together do the entire sieving, mixing, and the print preparation of the print. And now you can easily just take this material core unit out. So you see it's not a desktop solution, it's not a benchtop solution, it's really a standalone solution that you can easily with one hand guide into the production system. We have to pick this cable up because this is for the creative director behind the camera. Thank you, Yannick, for this. And then the stick muss noch angehen. Yep. Then we can just easily move this material core unit, maybe again for the audience, just to see the smooth surface on the top, about how fantastically equally it's leveraged. We can move this material core unit into the laser sintering station. So before we do that and start that, let me just explain you a few basic things about the Sintratec S2 starter cell. So this is a fantastic, perfect application enabling S2 starter cell. It contains 3 high-tech machines. We have the laser sintering station, where the entire laser intelligence is in, and of course the laser on its own. We have the material core unit, which we have totally separated from the laser sintering station to make sure that according to Sintratec customer feedbacks, thank you very much for that, you can easily exchange these material core units and basically create your production of the future. So you can easily just take a second, third, or fourth material core unit, and then you can extend your production solution. Yes, and good. Laser sintering station, material core unit, and what we have seen on the back was the material handling station. These 3 high-tech systems altogether comes for a starting price of approximately 40,000 euros. And I think from my perspective, not just because I'm a Sintratec representative, it's still the best standalone semi-automatic solution that you can have. Because with these application enabler, you can easily start, dig into the technology, and then extend your production according to your capabilities or needs. Good. So, then you move the material core unit into the laser sintering station. Did I do it correctly? You just drop this one down. Automatically, the laser sintering station connects with the material core unit. And Dario, please, you can see on this 4K camera system, you see that the software is guiding you step by step. So you can choose the printing option now. Then you have to choose the file you would like to get printed. You have to push this check mark or checkbox if the camera and some glasses have been cleaned, which are inside of this system. So there are protection glasses and IR glasses that have to be cleaned, but this goes very smoothly and automatic, basically, if you have a bit of a routine. And then, yes, you push this check mark, you start the process. The system is starting to heat up the material in the material core unit. Now, this takes about 30 to 45 minutes, I think. It's shown on the display. You see the material that you have chosen. You can see the height of the print. So it's 130 millimeters, so 13 centimeters of height. You see that the machine warm-up time is 44 minutes, and afterwards, the selective laser sintering process will start, and we will see this process live then on the display. And this is what we are going with in the second live session at 2:30, I think, yes. Good, so Dario, is there anything more you would like to mention to the audience?
So regarding the laser sintering system?
Yes, is there anything more? I mean, you're our service hero, our service engineer, is there something you should take care of? I mean, if you clean the glasses, you load the system, you do everything according to the manual, then usually you should not have any issue with the system itself.
So generally the sintering system is very easy to use and maintain system, as you do all the powder related stuff in the MHS. The laser precision part is kept free of powder and is low maintenance and
Good.
very easy to use. Yeah.
Good, yes. Yes, so basically there are just a few things you have to take care of. You have to clean the blade, you have to make sure that the surface is as smooth as possible, but this is automatically done by the system. And important is, I think as well, Dario is one of our service heroes. We have a team of multiple service engineers, many service engineers who are taking care of our clients. Basically, they always do a technology onboarding review as well, is that correct? To make sure that if you received the system, that you can smoothly, easily start into the process of using your selective laser sintering starter cell, the S2. Good. So maybe to show you just a bit for those who have not been attended yesterday.
Or you may want to show the parts, the other parts we're sintering today on the S2 itself. Can you do that?
Yes, the gliders, sure. I'll be back in a second. In a minute.
Because you said you build these into your own machine, right?
That is correct. So multiple of the parts that are basically assembled in the Sintratec S2 starter cell are made with our own systems. So are made in Sintratec S2 machines.
Show this close up.
Of course, you can show this close up if you see it, because my gloves are gray. These are gliders. And those are fit actually on this LMI chin, and they are placed. So if you come closer,
can you maybe show it in this one?
Sure, I can show it there as well.
The camera.
Yeah. So these are basically, as you can see it here, these are basically the same gliders that we have assembled in the Sintratec S2 starter cell. This is just one part out of many that we are already using in our own production to make sure that. We rely on this technology, rely on this solution and on the Sintratec S2. And you can see that these are really functional parts that we are using for daily operations as well.
Can you maybe show me what is sintered there? So you can actually see it, right? The little guide. Can you maybe show it with your finger?
This one?
Yeah.
Yes. So this one is exactly this one. Is that okay?
Perfect.
I think this was okay to see, yeah?
Yeah, you can see it.
Good.
Can you maybe say, you have other parts laser sintered as well in our system, right?
Yeah, we have multiple of those parts that I think the other ones are assembled in the system, so I cannot open it up now. But I can show you maybe something, a fantastic design to have a look at the complexity of the parts that we can do. Janek, maybe you come over here as well. So what you see here, for example, is Big Al. Big Al is a dinosaur that was, I think, living in Switzerland many thousand years ago. And this part contains about, I think, 400 parts. It's a very complex model of a dinosaur, and this was fully printed in one Sintratec S2 print cage. Of course, for such small parts and assemblies, you have to be very careful to depowder them, that they are not breaking, because they're very, very thin. And this process we will show you this afternoon as well in the depowdering session, which takes place, I think, at 3:30. Good.
Questions so far? Yeah, let's do some questions, I guess.
Oh, we have a question from the audience. Yes, please.
Yes, there's one question from Helder. She says, yesterday and it seems today you have not had a change to see the inside laser S2 box. Is there a reason why?
Helder, thank you very much for your question. You are asking us that yesterday and today we have not had a chance to see the inside laser S2 box. Is there a reason why? Yeah, basically there is a reason why. I mean, the laser is operating, so we are not allowed to open this one up. So if you would like to have any more specific information, Helder, please use the chance. Go on to our website, www.sintratec.com, and you can organize a separate meeting with us, so with me personally as well, and I'm more than happy to show you in the second private meeting then everything that you would like to hear afterwards as well, yeah? Good?
We have another question from HC and Carbo. How much time it takes to automatically sieve a full load?
All right, the question was coming from HC and Carbo. Thank you very much. The question is, please?
Yes.
How much time does it take to automatically sieve a full load on the S2 system? The question is good and correct. We will show this in the second session where we will do or show the live laser sintering. We will show you as well about how we sieving and mixing in the material handling station and the material core unit a full PA12 print ready bottle. This takes usually, to answer your question, 40 to 45 minutes.
Maybe we have some time left. What's the time?
Yeah, so it's 20 minutes before 2 p.m.
All right.
Yeah, I think this was a good start into the first session of today. Do we have any more questions, Vanessa, now?
Not yet. No.
Good, not
You
yet.
can talk about
Yes, I can
customer.
guide you briefly into the history of Sintratec itself. So when Sintratec started 2014, it was then three fantastic engineers, Dominic, Christian and Joscha, have created this world's first and still only, it's the world's first and still only selective laser sintering assembly kit. So to build or to assemble this machine, it takes you between 3 to 5 days. So this is an assembly kit you build step by step with a fantastic manual. And after you assemble this system, basically you have all the knowledge that you need. You understand almost everything about the technological side from selective laser sintering. So this machine comes for 5,000 euros approximately. We still have it, we still sell it. It's 28 kilograms of weight, and many of our, or multiple of our clients, mostly universities and research institutes, are using these systems to get used to the technology, or maybe to do science, operate, or research on new materials for the 3D printing industry. Let me just give you one fantastic example before I answer the third question. Good. So we have here the example of Fabrics. So Fabrizio and his team, basically the team of Professor Simon Gaisford from UCL in London, decided to create this company Fabrics. And they basically started with this low price solution for 5,000 euros. And what they are doing is basically they are sintering a different kind of material. It's a kind of paracetamol that they are sintering. So this is the powder, the rough powder. Thank you very much, Fabrizio, for passing this to us. Yes. And you see they are started with one of these Sintratec kits, and now they have multiple ones in their research lab because they really have deep technology know-how when they assembled this system and know how to operate it and know how to use it for research. So it's a fantastic science project. This customer use case story is on our website, as many others as well. So if you go to our website or onto our YouTube channel, please make sure you follow it, because we have S2 or Sintratec S2 workflow videos. And we have many very interesting customer use cases from different kinds of customers, from industry, medical, down to design, which we are talking about today, to education and research. Yes. Good, we have another question, Vanessa. What's the question?
Corey asks if there is a step-by-step video made on the Sintratec kit. He managed to get a machine, she managed to get a machine 3 weeks ago in South Africa.
All right, so Corey, yes, there is a step-by-step video on our YouTube channel. I think it's basically not showing you all of the assembly steps, because a video this will take 3 to 5 days to show that. But you see a so-called, how do you call it, a time lapse of how the machine was assembled. And if you are a customer of Sintratec, you have of course the right to interact with our service heroes, like Dario is one of them, on the customer portal. Please make sure you just get your customer portal activated. It should be automatically, and then you can interact and get in touch with our service engineers, yes, if you have any questions.
For people who want the benchtop system, maybe what's the major benefit, you would say, of the kit, if you want to do like research?
Yeah, so I think the major benefit of the Sintratec kit are three things. Basically, it comes for a very affordable price. It's of course not for free, but if you compare it to the price of 5,000 euros, that's a good mountain bike or a fantastic camera system today. So it's a very low price solution. Secondly, you assemble it and learn everything about the technology. And thirdly, you have open parameters in this machine so that you can manipulate things like the laser wavelength, the inside temperature, and the surface temperature of the material. And these three parameters basically, to start into this research level of, let's say, hands-on, it's absolutely enough. So again, fantastic machine. We still have it. You can buy it on our shop, or get in touch with us, the Sintratec kit. Then we have had the Sintratec S1. For the S1, we have a few of these machines left, but we stopped production because it came to the end of its product life cycle. And of course, because of the many fantastic customer feedbacks, we have decided then or our R&D team has decided together with us to create the fantastic Sintratec S2 starter cell. Good, of course, we have a few peripherals as well. So we have the Sintratec S2 starter cell, we have a blasting station and a polishing station. So with these 5 machines, starter cell, 1, 2, 3 high-tech systems, peripherals, polishing station, blasting station, you are fully ready to go and to dig in hands-on into selective laser sintering technology. Yes?
You showed us some parts yesterday, maybe you can show some more for people who have not really seen laser sinter parts. We don't know how these parts look. Yesterday we heard why they are gray.
Sure, yes, I think this is the part that we are sintering live today. So this is a very complex compliant mechanism done by Mr. Stephan Henrich. Hello Stephan again, he's going to have the second talk today to our customers. He will be live there as well, so please do not hesitate to ask him questions. And as you can see, this compliant mechanism came out of the Sintratec S2, and this is what we are printing today. And you see the possibilities that you have there are really fantastic. So it's complex shapes with freedom of form you can generate, and even assemblies, yes. Good. So in addition, maybe for those who have not seen it, this is then the part where Tobias Oesch is talking afterwards in the ETHEC project. So this is the casing, basically a display holder for his e-bike. So it's a very robust, huge part. Of course, that's not the funny part these days. We had multiple medical parts that we have had to do, prototypes or masks, all these sort of things. And yes, this one basically is a custom part from...
student project, by the way.
It was also a student project, yeah, it was from the project called...
Poseidon Tap.
The Poseidon Tap. So if you would like to see how the Poseidon Tap team has used this part on its project, it's one of the fantastic customer use cases on our website as well. Good, we have another question just before I answer this one. This is a demo sample, so it was not designed by us, but we printed it out. So if anyone is asking us about how big you can print on a Sintratec S2 starter cell, our question back is, how big can you think? Because this is an assembly of multiple parts that was printed in one print range, and you can see it's perfectly working. If you now take the attention away from this sword and think about maybe a tool that you can use instead of going onto a ladder to detach some connections or connectors, like maybe fire alarm controls on a camping space or something, these are perfect examples for tooling as well. Yes. So we have a question. Vanessa?
Yes. Tomasz Weiss says, hello Gabor, greetings from Poland. Are you working on new materials for S2? Can you tell me something more about it?
Good, so Mr. Tomasz Weiss from Poland, hello. It's a great pleasure to have visitors from Poland as well. The question was, is Sintratec working on new materials? And yes, we are working on new materials. So we have already shown last year that we are working on new materials like glass-filled PA12, carbon-filled PA12, and polypropylene. So this was what we officially showed at the last Formnext. We didn't finish this process, but we will do that soon. And of course, we are working on many more materials. They are all actually not for the public now, because we just want to tell you about it if it's done. Good. So Tomasz, I hope I was able to answer the question. And otherwise, please organize a meeting with me if you would like to have more deeper insights. Good. Vanessa, do we have more questions left? All right. I think basically this was the first live session of today. We did the print preparation, so we showed you how we placed the STL files in our Sintratec Central House-owned software. Dario, our service hero, was so kind to support me in setting up the print. And we will be back at 2:30 with showing you, or we are going to show you how the laser sintering process is working live. We are going to watch it on the screen as well, explain a bit more details about it. And yeah, so do we have another question? Oh, yes, please.
Justin asks, do we need to be concerned with wall thickness in our designs?
Good, Justin, thank you very much for the question. I'm just repeating it. Do we have to be concerned with wall thicknesses in the designs? Yes, you have. So this means, I think concern is not the right word, but if you would like to have strong and good parts as well that are functionally working like this one, we recommend to have a wall thickness of 0.6 millimeter upwards to make sure that these parts are mechanically then stable as well. because we can go thinner, but the question is, how long does it hold until it breaks? So 0.6 millimeter obursts, depending on the construction and the application that you need. This is, of course, something we recommend. And if you're unsure, Justin, we have a house-on Sintratec print service. So send us your STL file, we will print it for you, and then you can have a hands-on look about how it looks like and if the quality is really fulfilling your expectations then. Good. Did you answer all questions so far, Vanessa? Yes. Okay, it was a fantastic and lovely interaction with you guys. So we are now going to start the next program. So Mr. Tobias Oesch from the ETHEC City project will talk about future motorbikes and about e-mobility. It's a fantastic and thrilling interview that we held with him. So stay tuned, and I and the team will be back at 2:30 for you for the next live session. Thank you very much for your time.
Thank you.
Hello everybody and welcome to this Sintratec Talk. Today I'm joined by Tobias Oesch. You might know him from our most recent customer story about ETHEC City. Hello Tobias.
Hello Yannick.
So first of all, how are you doing in these strange pandemic times?
We're doing pretty fine, although our our final project, our final days in the project were a bit,
Stressful.
issued with stressful. Yeah, were a bit stressful.
So we recently published a customer use case about this interesting project, ETHEC City. So for those who have not read or seen that story yet, can you give maybe a short introduction about yourself and what the project is?
Yes, of course. I am Tobias Oesch. I am studying mechanical engineering at the ETH in Zurich. In the last year, we started this project ETHEC City. I was technical leader in there as we developed an electric motorcycle with a group of 10 people.
Mm-hmm. So this motorcycle, we can see it in that story. It has a special type of, you explained the recuperation method, I think, which makes this pretty ingenious. Can you summarize that for people who have never heard of what recuperation actually means?
Yes, I can. Well, our concept was built on 2 hub wheel motors. So we built a motorcycle with an engine in each wheel, with a motor in each wheel. These electric motors can be used as generators, such that we can recuperate the whole braking energy while driving. Because motorcycles are usually built with just one electric motor, especially, the electric motorcycles. We wanted to improve this kind of motorcycles, such that we really used 2 motors. For example, the front wheel motor is mainly used for the braking and the recuperation, because with the back motor you can just use a limited amount of energy in the braking, because you have the whole weight on the front wheel and not on the back wheel. So you can have larger braking moments at the front wheel, and therefore also more energy to recuperate.
Mm-hmm. So what's the benefit of that mostly? Would you say, what was the goal? What did you want to impact the most? Was it like battery life or the range of the motorcycle?
Well, there were several advantages. One big advantage is to enlarge the range of the motorcycle. With the whole recuperation system, you can build, or you can use smaller batteries, such that the motorcycle becomes lighter and still have a big range to give also the customer much flexibility.
Mm-hmm. So when we visited you, the motorcycle wasn't quite finished, right? So can you maybe give us an update on where it is right now? Did you move on to complete it, or what's the status? Or did Corona put up even more delays in regards to that?
Yeah, well, Corona had a big impact on our project, especially in the spring. But we wanted to finish this project in September, and we weren't able to achieve that. Also because of lack of sponsors and other issues like wrong parts or delayed parts. So we had to continue the project until now. The ETHEC City was at the exhibition in the ETH Zurich for around a month. So we weren't able to improve it and finish it. So we want to start next week and develop it further, and also finish this project such that we can really test it and drive it.
All right, so you're picking it up again. Can you maybe tell us what's left for you to do now before you can actually test it?
Yes, well, we had some problems with the electromagnetic fields. So we have to improve that, such that we can really drive safely. That is one of the biggest requirements, the safety in the project. So we want to start the test when we are ready. So we don't want to
rush it, right?
Yeah, we don't want to rush it. Yeah.
Mm. So you showed us in the project that you 3D printed a variety of parts of the motorcycle, but you didn't plan to include that from the beginning, correct?
Yeah, well, 3D printed parts have many benefits, many advantages, but also some disadvantages. But our goal was to build a motorcycle which can later be built in a series, for example, and then the 3D printing, the additive manufacturing, isn't always the best solution there. But as a prototype, it was really useful.
Mm-hmm. So you told us back then what kind of technologies you used. Can you maybe summarize again a bit what types of additive technologies you implemented into your final prototype?
Yes, well, depending on the requirements, on the mechanical requirements, or for example, the strength, we had some different methods. For example, we used selective laser melting for some parts, but also the selective laser sintering, especially for design parts, such as the casing of the whole motorcycle. And we also used the SLA method for a custom light, but it's also a design part, and it was just it was a prototype for our prototype.
So what would you say was the biggest success you had when implementing 3D printing? Which component maybe would you say was very particularly successful?
Well, there were many successful components. Well, the most of the components were successful. For example, the whole casing, the casing is built out of about 10 or 15 parts, single parts, and it was quite difficult for us to determine the tolerances between the parts. But with the 3D printing, especially the selective laser sintering, it was relatively easy, but we struggled a bit with the thermal warping of the parts. But in the end, we had just 1 or 2 parts which were a bit warped.
They were too big or too small, basically, you're saying?
Mostly they fitted, but also because we exchanged a lot of information between the manufacturer and our project, so we could talk also with Sintratec, what were the requirements, and also the requirements for the tolerances and the parts, but it wasn't a big problem there.
So you're finishing up the project, and you sent us some more parts to print for you, actually, in the past few days. So can you tell us a bit more about what kind of parts these are and what you pretty much need now to finalize the motorcycle?
Yes, well, at the end of the project, well, not the real end, but our goal, we had some parts left, so we had to prioritize some parts to really finish the motorcycle. But there are some smaller design parts, especially like the front fender, which we want to manufacture now. So we came to Sintratec to again do this with you.
Mm-hmm. So you have like the majority of your casing, I think, is safe to say is printed using selective laser sintering. Can you maybe give us a bit your insight, what you would say is the benefit of using that particular method, and let's say not fused deposition modeling or something like that?
Well, the fused deposition modeling is also good, but the requirements for the material aren't that good like we want it to be. So the SLS parts had a bigger strength, so they can resist impacts, and also especially the casing is used by the driver or other effects like like the wind or weather. So the SLS parts were definitely the better solution than FDM parts.
Mm-hmm. Did you from the beginning say, let's use SLS, or did you first maybe test other technologies as well and evaluate?
Well, we discussed in the team which manufacturing methods would be suitable for some special parts, and especially the casing isn't usually made of SLS or in general additive manufacturing, especially like carbon fiber or glass fiber. You just laminate these parts, but it isn't that easy, and you need also the opportunity and the possibility to do this, or again a manufacturer, but it's very expensive. With the SLS technology, we were able to build cheap prototype parts for our casing, which were also suitable for end use parts. Yeah, so we didn't have to print them just as a prototype. For our prototype, we can really use it in the end.
So they had these mechanical properties that you were looking for in these parts, basically.
Yeah, for the casing, definitely, yeah.
Okay, interesting. So one question I have as well about you are a group of students, for those who don't know the project, from the ETH, but I think also when it came to the design of the motorcycle, which is like this awesome futuristic looking vehicle. I think you work together with the ETHEC, how it's called, the art school and product or industrial designers from there.
Not really. Well, we work mostly with the FHNW in Basel.
Oh, okay.
But we had one student from the ETHEC, but the design was mainly part of the FHNW.
I'm interested into, let's say, if the implementation of 3D printing methods, if that affected the design choices. You know what I mean? Like, did they maybe gain more freedoms by choosing certain types, or was it the other way around? It was more like they started designing and you found the best solution for that.
Exactly. It was more like the second option. They really started designing. They made their concepts, and it took also a lot of time. So they had a half a year to develop these concepts, the students from the FHNW. And then after this half year, we had to discuss them in our team, in the ETHEC City team, how we manufacture these parts, how we manufacture the casing. It was like this way. So we had the parts, we had to search manufacturing methods, and there weren't many options. And especially the additive manufacturing looks very simple and easy for engineers. But there are some struggles with the additive manufacturing, which we didn't realize at first.
Can you give an example?
Well, as I said, the thermal warping was one part, but also the costs which come with the additive manufacturing. It always seems very cheap, but it isn't. But it has a price. But the requirements and the product you receive is really good. So the price is really fair for the products.
So a price to quality ratio that you think
that's definitely very good. Yeah, that's definitely good.
Yeah, you told us that it was the most cost-effective solution for your prototype and realizing the prototype. So maybe what would you say other people like developing in that sector, developing vehicles, where do you see the benefit of these technologies there? Maybe can you tell us a bit about that?
Well, with the additive manufacturing technologies, you gain more degrees of freedom in the construction phase. So you can build complexer parts such that the parts become lighter. And you can also include several parts with several functions into one part. but it's pretty complex to manufacture. But with the selective laser sintering, for example, you are able to manufacture these parts, and so I see a future for these technologies, for the additive manufacturing technologies, in especially also the mobility sector.
Interesting. So where do you see ETHEC going then? Like, you are now in the process of finishing it. The last parts are coming, and then you're probably going to test it. Or what are the next steps for that project?
Yeah, well, we really want to test it. So many students, they started their master, and they had to go abroad. But we want to keep our team, and we want to finish this project, and also to test it, to drive it, to look what we achieved in the last year. And it's hard to say where this project goes. Well, yeah, especially in these times with COVID-19 and etc.
Yeah, so that delayed the whole thing, but it's nice that you still want to finish it. I guess there's a bit of ambition behind it too. Yeah, even though technically, I guess it was your bachelor project, I think, right?
It was a part of the bachelor. Yeah, these focus projects. Yeah.
So technically, you have that degree now, so you could technically move on without it, right? But you
definitely, yeah. But we had so many sponsors which helped us. We want to give something back, so we want them to see that our project works, that our motorcycle works. So we want to let them know that it was able to do this with their help, and so we own it a bit to our sponsors, but also to ourselves. So we invested like a whole year, and we want to see it drive. Yeah.
So what would be the plan? You would like test drive it somewhere, or is there a concrete plan for that already?
Yeah, well, we had many test drives planned, but some technical issues always came along and interrupted everything. So we had to cancel them. But I think we will definitely be able to do this one, or at least once. Yeah.
All right. So one other question I think I've read somewhere in the comments we've got about the story. The surface quality, like the exterior of your bike, of the motorcycle, it looks really outstanding. Like the finish of it is very nice. Can you maybe tell us a bit about? I guess you didn't do that yourselves, but can you maybe tell us a bit more about the process? Because that's always a question too. Like, you have these SLS parts that, for example, that are a bit rough, even though they are polished, but to make them look like this, what do you have to do?
Yeah, well, this is a real struggle with the SLS parts. So there are many benefits, but this is one big disadvantage, that the roughness of the surface isn't that flat, such that you can just paint it and it looks good. So we had also a sponsor who painted the whole casing, so every SLS part. And they also struggled with it to prepare the parts, and then also to paint them. Also, the priming is a big part of it, and that all without changing the tolerances between the parts. So it's very difficult, and it comes with a big effort. Yeah.
Have you heard of the company Dimension? Does that ring a bell to you?
Dimension?
Yeah.
No, I haven't heard it. No.
Okay, because they produce machinery exactly for that, for like the post-processing of SLS parts, for instance, and coloring as well. It's pretty interesting.
That's pretty cool. Yeah.
Yeah, but anyways, let's go back to this motorcycle. So once it has been, let's say, successfully driven, what happens then to the motorbike?
Well, we hope that there is a following project, like the focus project we had, such that we can improve that and make a new generation of the ETHEC. The ETHEC CDEs.
Do you mean like
Yeah.
is then that still continued by you, or is that then like new bachelor students who do their focus project on that?
Well, yeah, we have to start our masters one day. So yeah, it costs a lot of time. So we have to gain new members and yeah, probably continue this project as we want to. But our team can't be in this project forever. So we have to do our masters, and this it costs time, and you can't do both. Yeah.
So you would pass it on, or try to pass it on to the next students who continue, in your eyes, should continue that project, or what would?
Yeah, well, if there's an opportunity, of course, yeah, we will. But it's hard to create these opportunities, and yeah, we'll see. We will see, but we will definitely not give up. Soon.
In your ideal world, when you could like define where this project goes, where would you see it going? Like thinking big, like you said in the video as well. You and your team, you want to change the e-mobility of our urban and suburban life. So what's your big vision for ETHEC?
Well, our vision at the start of the project was to build a motorcycle which impacts the mobility, like the everyday mobility. So we want to reach people in suburbs, in the urbs, to make mobility more sustainable. And it is a challenge, especially in our society, to have a sustainable mobility with respect to the climate change. And in a perfect world, I see our project as like a Tesla for motorcycles. But it's a big dream, yeah.
Tesla, watch out for ETHEC. That sounds great. Yeah, I'm looking forward to see, and I think everybody who has seen the customer story is looking forward to see where it goes, and maybe even the testing as well, to have like a follow-up on that. We're of course looking forward to that as well from Sintratec as one of the sponsors. Do you maybe want to say a little last words about the project, about your sponsors, maybe that you want?
Well, yes. Well, definitely our sponsors, and especially also Sintratec. I want to thank to all of them. And this project wasn't able to do without the help of many companies and people. Which were there to help and to support us in some hard times, I'll say. And yes, thank you for the talk with you, Yannick.
Yeah, thank you very much for your time, and I hope it was insightful for everybody who was listening, and of course,
yes, I hope too.
Yeah, I'm looking forward to hear again from you and the ETHEC project. I'm sure it wasn't the last time we've heard of it, and yeah, hopefully next time we see it testing in action.
Yes,
I'm really looking forward to that.
Hopefully.
Yeah. All right, thank you very much.
Thank you,
Tobias, and thank you everybody for listening and tuning in. And we will of course continue with our Formnext program, so stay tuned and see you soon.
back in the Sintratec headquarters in Brugg, Switzerland. We are now basically doing our second live session of this day. So this afternoon we already showed you how to prepare and to set up a print job on the Sintratec S2 starter cell. And what we are printing today is this compliant mechanism. So is this on focus, Janek?
Hold on. Now.
Good, so we are printing this fantastic mechanic compliant mechanism, which is designed by Mr. Stephan Henrich, who will have his technology talk afterwards. And let me show you now how this print actually is live doing. And I will get, again, assistance from our service engineer, Dario Arcangeli. Good. So for those who attended before, we loaded the systems, we started the print job. So the print container, the material core unit was heating up. It took us about 30 to 45 minutes to do that. And basically the lights are indicating green now. So this means that the machine is actively live laser sintering now. You see that on this fantastic 4K camera system, we have different kind of options. We are now watching the print job and some of its parameters, I would say. We have the option, Dario, if you would assist me, to go into the live view mode. And we have the option to check the temperatures, yes. Good, so now you see actually what is happening live. I hope the focus is working for you. So we are creating now layer by layer, always 100 microns, and are sintering this complex form together into this compliant mechanism. So what you see now is basically the laser is actively sintering the top surface. Now you see the coater is passing by and creating or putting the second or the next layer of material on the already sintered layer. And you see this is not speed up, this is live. So this is the speed of the laser from the Sintratec S2 starter cell. It's a pretty fast laser, I will guess, a pretty powerful laser as well. Dario, is there something you would like to mention? So what you see now basically is you see exactly the laser sinter process from the top. So the camera is placed over here, and now, yeah.
So the camera is like looking at the powder bed from the direction the laser is coming from. You can see each layer which is sintered. You can see if you have an issue.
Yes, so what Dario is saying basically, because he doesn't have a microphone and according to COVID, I can't give you mine now. So really, what you see is the coater passing by, putting the next layer of powder on it, and now the laser is the surface is heated up, and the laser is basically moving and does every 100 microns of layer height, basically the movement. Yes, we have a question.
Yes. Helder asks, I see the printing dimension of the S2 for printing an item is much more on the Z-axis and less on the XY axis. Is there a specific reason for that?
Dario, could you understand? Yeah, I think the question from Helder, thank you very much for this, was why the Z-axis is higher than the XY.
Yes.
Is that correct? So basically, yeah, I think the print height is just what we created on the Sintratec S2 starter cell according to the many feedbacks of our Sintratec existing clients. So this was exactly the print range they wanted to have, to be able to create small batch production of small mid-sized parts, and especially long parts, which are basically a hand size. So this is basically the reason why. And the engines are moving the platform up, so 100 microns, and this is the print range that we have defined, yeah. I hope this was okay if we have answered your question, Helder. Oh, basically, can you hold this one? There was another question from Helder before, which we didn't manage to answer, I think. So the question was, we can go over here. I think, Helder, if I understood your question correctly, the question was, what is inside of the laser sintering system? Just give me a second. Good, so we can show you now the inside of the laser box, because this is of course not confidential. You see, this is a fantastic feature as well. So you can open up this cassette or this deck, and inside you will see that we have a fantastic heat system as well. We have the laser protection glasses, Helder, if this was your question, and the IR sensor glass. So these glasses we have to clean after every print job to make sure that we have the best quality again in the next print. So Helder, I hope this was your question. This is the laser box basically. So this is the cassette that you can detach easily to do the every time service that you have to do before you start the machine again, cleaning the glasses.
I think you also asked why we didn't clean it before we started the print job, but we printed it before the stream, right?
That is correct, but we basically clean these glasses before every print job to make sure that we can start smoothly and in the time that we have given. We did this in advance, of course, yes. Good, so you see the lights indicating green. The laser is basically operating.
Can you show how the part is like placed in there maybe? Like how we...
Sure, so the part is exactly placed like Dario is showing it us now. So I can assist you in this one. So you see the top edges over here, and in the middle we have these small gliding parts that are basically produced for the Sintratec S2 system, the gliders. And yeah, so this is how the system operates. We have another feature here, so we can check the temperature range. So Dario, we have the top surface, we have the build cylinder, we have the preheat and the dome. So these all have different kind of temperatures, and this is what is actually being detected and checked in the system as well, I think, yeah. Good, so what is the actual sintering temperature now?
So the surface temperature is what it says, the temperature of the surface, and it's just below the melting point of the PA12 in this case, and gets heated up to the melting point or the sintering point with the laser. Then we see the build cylinder, like where the already made part is surrounded by, which is heated as well, heat controlled, so we don't have any warping, no tensions from cooling down. We have the preheaters, which preheat the powder which is getting moved onto the build surface, so that you don't cool it down every time you coat the new layer. And then we have the dome temperature, which is more or less like the temperature underneath the laser.
Good, so sorry for this interruption. I mean, this is a live event, so this is not made up. Dario, who is assisting me in this fantastic live talk today, is having his birthday. He has taken his day not off. He's here with us, showing to our clients about how the technology is working, and therefore, Dario, we wish you best of luck. Happy birthday from me and the entire Sintratec team. This is just a small interruption. We will continue, of course, the live chat as well. But I think, yeah, we did prepare some small things for you. We know that you don't like the sweets that much, so this is a typical Swiss cheese cake. And I hope after the presentation that you can enjoy it. Is that okay? So happy birthday. Yeah, thank you very much for the team. And good. So before the candle is melting, I think actually we will continue. So pass it there and enjoy it afterwards. Best of luck for your birthday today. Good. So where did we stand? The laser sintering process is actually working. And now, because we have time left, we are going to show you another very important step of the Sintratec S2 starter cell. We are showing to you how we are sieving, mixing, and refreshing the material in the material handling station. Good. So let's go over there. Good, so what you see here is the material core unit is placed in the material handling station. And here we are now filling in. Dario, if you will be so kind to assist me. We are filling the already used material into this print container because we can reuse the material that has not been sintered again.
What ratio? Can you maybe...
Yes, so people ask us about the mix ratio or the refresh ratio. Basically, we are using 70% used material, and we mix it up with 30%, so 30 virgin material, what we call Sintratec virgin powder. Exactly, exactly. Yeah, that's a fantastic rate in the industry as well. It's one of the best rates. Dario is now filling in the used powder. You see we have an industrial sieve, which is basically sintering out the bigger parts of the corn. You can come closer. So again, there is a step-by-step guidance in the software, which is exactly showing you what you need to do. So the orange part is now what he's filling in, and the blue part is the Sintratec virgin powder, which is basically coming in the middle container then. Pas met gap. Okay.
Ah, der kann Ding hat.
Ja, ja, ist gut. Das ist gut. Good, so now we're filling in the virgin powder, because if we mix used and virgin powder together with a mix ratio of 70% used and 30% fresh powder, the system will automatically start the sieving process. So we have over here an industrial sieve with an engine that is shaking and is then basically cleaning out the used powder of the rest particles, the cons that we should not be put again into the sintering system. This is an important step in process. It's not complicated, but be aware that the mix ratio and the parameters that have been especially engineered for this material are very important to get the best industrial quality out of the Sintratec S2 starter cells. Good.
So the powder you get out of this mixing is then used directly for printing, right?
Yes, and this tool, the spatula, I think you will use this one as well. Basically, again, you are condensing the material a bit. You can see this perfectly. It shrinks a bit down.
Maybe again you can say we have the whole workflow as well as a video.
Yes, because the Sintratec S2 starter cell is the perfect semi-automatic application handling system to start with. We have the laser sintering system, we have the material core unit and the material handling station together. And this is a semi-automatic process of sieving and mixing the material again. And you see now Dario is moving the platforms up. And when this is done, the engine on the sieve will start to shake. And when the engine starts to shake, the coater will move this material onto the sieve. Is that correct, Dario? And what falls down in the print container actually, or the powder container, is then the sieved material that you can reuse in the Sintratec S2 starter cell. Correct?
Yeah.
Good. So you see now the middle cylinder is moving up.
So you can do this parallel, right, while we print.
That is correct. So you can print if you have a laser sintering station, if you have two material core units. As stated in the beginning of this afternoon, you can easily extend your production capabilities. So one material core unit is in the laser sintering station, lasering or sintering now live. The second one is there for the print preparation. So we are mixing here the 70% used and 30% fresh material together. Yeah, and Dario did it now, and you see that by pushing on to the next step, where you are guided one by one, or step by step, the engine starts to shake, and the coater will push the material into this fantastic solution, where we are basically sieving the unusable particles out of the material, that you can reuse this powder then again. Good, so again the platforms are moving up. Used virgin, the coater is starting to move. It moves the powder onto the sieve. The sieve is automatically shaking. The powder falls down. What happens or what stays inside of the container you can reuse. The rest we will see afterwards is waste, and you can throw it away according to the local safety and security guidelines, I think, yeah. Good.
If you have any questions, now would be a good time, I guess, to answer them.
Yeah, so far we managed to answer all the questions in the chat. It's a quarter, or let's say it's...
But if you have questions, just put your ask.
Yeah, it's almost 3 p.m. now, so if there are no questions, we will finish this second session of showing you about how the laser sintering process is actually happening live, showing you about how we set up the sieving process, and yeah, we will be back at 4:30, I think then, and please enjoy the next session, which starts in, I think, 15 minutes.
So let's check out maybe the printing first before we leave. Huh?
Yeah, okay, let's go back to the printing.
Maybe some questions come up. Maybe we should first see the status, how it's going.
Yes, so again, you can see in the live view on this 4K camera system, you can see how the system is live printing. So again, as you were asking, or one of the questions in the chat was, can you use multiple systems in the same time? Yes, you can. Laser sintering station, material core unit is sintering now. And on the back, you have the material handling station and one of these material core units to have this perfect, economically working recycling mode or cyclus that you can easily operate and that you do not wasting too much time in your production. So reducing the production downtime is a very important point for our customers as well, and this is what we are basically doing here, yeah.
Okay. What do we have coming up next?
Yeah, so I think we managed to answer all of the questions. So next is this fantastic technology presentation of Mr. Stephan Henrich, who created this outstanding compliant mechanism, this bottle holder. So please stay tuned and enjoy this presentation. Mr. Henrich is live in the chat as well. He will answer all the questions from people who are interested in industrial design, how to set up industrial designs for compliant mechanisms. And afterwards, at 3:30, we will be back with live depowdering of this part in the Sintratec S2 starter cell. Good. So I hope you enjoyed the second live session of today. Stay tuned for the third one, and yeah, see you later then.
Bye.
Bye. Hello and welcome everybody to this Sintratec Talk. We are now joined by Stephan Henrich of Stephan Henrich Robotic Design and Architecture, who is Sintratec technology user since many years now. Hello Stephan, how are you?
I'm fine, Gabor. Thank you. How are you?
I'm very well. I'm looking forward to this fantastic and exciting chat with you. Good. So, Stephan, it's not the first time that we are talking to you. We have basically produced a customer use case with you, and we have done already 2 webinars who have been watched by many thousands of people. So thank you very much again for taking your time. Nevertheless, for those people who do not know you, can you give please a short introduction about yourself and what you do?
Thank you, Gabor. Well, I have this design studio in Stuttgart, Germany. It's called Stephan Henrich Robotic Design und Architektur. And it's a bit also what I do there. I do robotics, design, and architecture. And I have this specialization in design for additive manufacturing, more specifically in SLS. So as a customer of Sintratec with a S2 system now, I can produce in-house and develop parts in-house. And yeah, that's my new toy.
All right, so thank you very much for this short introduction. Basically, the reason why we decided to do this technology talk with you is that I recently came across with one of your designs that you have printed on our Sintratec S2 system. So as a person with a technical background, as I am, I was astonished, of course, about its functionality. And I have totally forgotten about the technical term, and you told me it's a so-called compliant mechanism. So could you please explain to the audience what a compliant mechanism actually is?
Yes, so a compliant mechanism is, so to say, an alternative kinematic way to construct. So a common scissor, for example, consists out of 2 rigid parts that are connected with a screw in the center to allow motion, to make a scissor work as a scissor. Now, to rethink the scissor employing a compliant mechanism would make it possible to build the device from one continuous topology, so one part that don't need to be assembled afterwards. So the rotation that enables the motion that happens concentrated in one point would then be needed to be distributed onto larger areas of the part, employing elastic bendable zones. And the art is, of course, to make the same exact cutting result, or even better cutting results with this new mechanism. Actually, the first scissors or early scissors were constructed as compliant mechanisms.
Okay, good. Thank you very much for this explanation. By digging deeper into this topic, I found a nice channel on YouTube which was called Veritasium. Do you know this one?
I saw this one. I had this conversation with Stephan Noser from Sintratec lately, and he was showing me this one. I didn't know before. Huh?
All right. Because on this channel, a professor called Larry Howell, I think it was, from the Brigham University, tells the audience or the viewers about how he is using compliant mechanisms to prevent that nuclear weapons can be set off accidentally. So it is used for security and arming, which is basically an awesome example, which I didn't thought about. So if you already watched it, it's okay. Otherwise, we will put the link into the chat for the audience. So I think Professor Howell even wrote a book about compliant mechanisms. It's definitely worth that I'll get one of these examples then. So from your perspective, is there a, so to say, archetype of a compliant mechanism?
Yes, I would say the archetype or the compliant mechanism everyone uses and knows are the tweezers that are used for manicure. It's a very simple example. But also another example could be the fasteners that are used for bags or backpacks, where you squeeze with your 2 fingers to open them. You know what I mean? So these very simple, really widespread, everyday use devices. Huh?
Okay, good. So I think we will put a picture on that the audience sees what we are exactly talking about.
Sure.
So why should one make use of such a mechanism when conventional mechanisms work well enough?
Well, as I said, it's just an alternative way of constructing, but these mechanisms, compliant mechanisms, come with a number of advantages. So, for example, they reduce the number of parts needed to build the mechanism. This, of course, goes along with less assembly, which is time-consuming and maybe expensive. Also, less maintenance is then needed. It is very likely that such a build is easier to clean So you can imagine a place where hygiene plays a big role, maybe in food fabrication. The food industry might be a good spot to employ these mechanisms. Very often they are very reliable. So you mentioned already this nuclear weapon safety device. Imagine if this mechanism wouldn't be reliable, it could end in a tragedy, of course. Yeah, and also the more reliable a thing is, the less servers it will need over its lifespan.
All right, so basically it ends up in the reduction of service costs as well. It is speeding up the assembly process, which is no longer given. So that's an interesting point of view on this compliant mechanism constructions. As a huge fan of nature, being most of my free time outside in the nature with my family, I had a nice experience last weekend with a bumblebee. And don't worry, I'm not going to bore the audience about it, but it somehow put me into the direction of bionics. So do you see any role models from nature for compliant mechanisms?
First of all, I think it really makes great sense to look for these mechanisms, or let's say analogies of these mechanisms in nature. Evolution in general is a fantastic, so to say, inventor, if you want. The first thing that comes to my mind is the so-called fin ray effect. So when you have a look at how a skeleton and the muscles of a fish work together, you can observe something surprising. The construction of the back spine leads to the effect that the fish's tail is bending towards the water stream or the water flow instead of bending away from it, which would be my first intuition, right? So the fish skeleton uses the trick to save energy while moving forward. Yeah, and this principle has been translated into a technical mechanism. That is actually what bionics is doing. And this mechanism works best when it is constructed in one continuous monolithic topology as a compliant mechanism. And there it's used as an example in robotics as a robotic gripper.
Okay. Any other examples off the top of your head?
What else? I think the way now I'm lacking the English word for this animal, the cicade. This little bug emitting this crazy noise during summertime. I think it produces this noise by moving its upper part of its body shell towards the lower part of the body shell, and I think it's the motion allowed to do this is also a compliant mechanism, but I'm actually not sure.
All right. I will look it up as well. So this seems to be a very interesting example from bionics. So what do you think have these mechanisms to do then more particularly with 3D printing and more specifically with selective laser sintering then?
Well, function integration is a big topic in construction for additive manufacturing because just the geometric freedom that you gain using 3D printing, you can pack way more functionality, for example, articulations in one single part. Maybe when you construct with conventional fabrication technologies, you are only able to reach this with complex assembly of larger groups of parts. So this is one great advantage of additive manufacturing. And of course, selective laser sintering as, in my opinion, the additive manufacturing technologies that allows most geometric freedom is most suitable here.
So if you compare SLS with FDM or SLA for the functionality that compliant mechanisms need, you think that the selective laser sintering technology is the most suitable for this application case, huh?
It's at least the one I have most experience in. I will admit it. There are nice examples of FDM compliant mechanisms. They also look a bit different. Sometimes they are more 2.5D, but they work pretty well. And you can learn a lot from these. But I think as I said, in SLS with the geometric freedom, you can make them move in different directions in one part. And in my eyes, that lies the biggest advantage. And so.
All right, good. Thank you very much for that. So Coming away or getting away from the technology side, going to the material side, which is also a very important part if it comes down to produce these compliant mechanisms at the end of the day. So what materials from your side, from your experience, do you think are suitable to build a compliant mechanism? Because you know that in selective laser sintering, there's a bunch of materials already existing or given. So what is your experience on this, or what do you think could be one of the materials which has the top advantage in this?
I personally prefer using polyamide 12 because you need a certain experience to predict how a part is behaving. So I have most experience in polyamide 12. That's a durable nylon that provides stiffness and elasticity in one single part. And this can be obtained by adjusting the thicknesses of the construction. So you have the possibility to seamlessly steer the elasticity that you want to get. But also TPU or TPE is materials used in SLS that have rubber-like properties can be employed to construct these mechanisms. Of course, the design would then need to be adapted to the material softnesses. They are, of course, softer, but also I think there's a big potential to be explored using TPU or TPE, for example.
Okay, so do you have a typical or practical example in which fields are they used already? Have you already seen, apart from your work, a compliant mechanism maybe produced on polyamide 12?
I think, as I mentioned before, closures and fasteners are examples. Of course, hand tools like pliers or tweezers. Nice examples explained in this YouTube channel from the professor you mentioned before. But also in aeronautics, there's an example of this beautifully complex-looking jet engine pivoting mechanism that is super lightweight and most important, super reliable, even under these harsh conditions where it has to serve in space, right? But also the field of robotics can profit from these mechanisms. These grippers are examples for that, yeah.
Okay. So, Stephan, can you give an example where you have implemented actually a compliant mechanism?
Of course. I did one robotic gripper, a parallel gripper, where I translated all these rotational joints into integral hinges. So there are no joints anymore, but integral hinges. So you have less maintenance. You have one continuous topology. You don't need to assemble all the sub parts to the final part then anymore. What else? I did the design of a wallet from SLS, also with the help of bendable parts or an assembly of bendable parts, all printed in one go. You can call this a compliant mechanism if you want. Let's say a simple compliant mechanism.
Thinking a bit out of the box, what do you think, or do you have any propositions where these compliant mechanisms could be used in the future?
Well, first of all, I think there are many fields where these mechanisms can be employed. Actually, also in combination with SLS as a fabrication technology, I actually should do a list or go through them systematically to see where this is possible. A thing that we can show today would be the bottle cage that I designed lately. That is also containing a
compliant mechanism then?
Of course, a compliant mechanism. It's a bottle cage that is used for a bicycle. It's a cage that actively grasps the bottle as you approach the bottle to the cage, which is pretty useful when you want to drink without stopping your ride. The mechanism is a closure that snaps as soon as you push the bottle over a certain point, and it snaps open when you pull the bottle out of the cage.
All right, good. I think we will see some pictures for our viewers then. Stephan, we covered the technology side, so the selective laser sintering side. We briefly talked about the material side, which both come together to make compliant mechanisms work. A very important question from my side is there as a construction person, as a person with a technical background, is there any special or specific software that is basically available to help design these mechanisms?
Well, first of all, it is very helpful if you are a good 3D modeler already. And then principally every known 3D CAD software on the market is suitable. So it is perfect when your software provides tools for drawing freeform or freeform surfaces. As I mentioned before, the possibility of steering elasticity by gradually adapting the thickness of your construction is important, and that I think can be drawn easily with freeform surfaces. And then, of course, there are engineering tools available for the case that you don't want to rely only on your experience.
Okay. Is it okay to ask what tools you are using?
Of course.
During your daily work?
Yeah, so when I know that the final part will be an SLS part, I really like to use polygon modelers because most 3D printing processes ask you in the end for an STL file. And this is a polygon format, and why not start with a polygon modeler from the beginning? And that's what I do. And I feel most at home in Cinema 4D as a modeling tool when it comes to this task. Yeah.
Okay, good. So maybe one final question from my side. Compliant mechanisms, very interesting. Why don't we see more of those?
I think you're right. That's what I say as well. They are very interesting. Well, I guess that there are just not so many places where this way of construction is taught. Then secondly, the applications are a bit hidden, so they're not so obvious at first sight. So you have to dig for them to employ these mechanisms. Yeah, and that's maybe the reason why only a few people are designing this way. I can imagine that they are getting more, even with the use of 3D printing technologies now. But at this moment, I would say there's potential to see more of them, as you say.
Okay, so Stephan, we have seen these mechanisms in nature, and we are trying to translate them into technical applications. In what field do you see the biggest potential, maybe with the help of additive manufacturing?
Yes, I would say robotics is an important field. In robotics, they are already employed in grippers and end effector systems, but I think they could be employed as well in the main robotic device. So there is potential, I would say. Then, as a trained architect, of course, I'm thinking always about applications in architecture. So a compliant mechanism for an opening device, an architectural element that opens up and closes, could be interesting to explore as well. Yeah.
All right, good. Thank you. So finally, do you have any inspirational sources, tips, or links for our audience where they can dig more into this topic of compliant mechanisms?
Well, the internet is full of this. If you do Google image search, you directly dive into things that you never saw before, maybe.
That's a good point. Yeah, often forgotten. Yeah.
And of course, there's literature about it. One book that is not exclusively about the topic, but it's about generative fabrication with polymers. It's a translation, it's a German book by Jannis Bräuninger, among others, in Springer Verlag. That's something I can really suggest having a look at. Otherwise, if you want to design these mechanisms, just have a look around you and at the objects that are surrounding you and rethink them as compliant mechanisms. That's actually great fun. And of course, you're most welcome to approach me if you have any question or even professional requests for design of these mechanisms. We will figure out what we can do together, right?
Okay, good. I think you have many pictures on your website as well. And this leads me to the end, basically. Thank you, Stephan, for your time. And thank you, everybody, for tuning in. if you have any questions, do not hesitate to contact us via chat or via email. And of course, make sure to visit Sintratec.com. Or if you would like to check out some of Stephan's fantastic designs or astonishing designs, stephanhenrich.de. Stay tuned for more Formnext action and have a lovely rest of the day.
Thank you, Gabor. Thank you, Sintratec.
Thank you, Stephan. Bye-bye.
Bye-bye.
Good, so hello back again. We are now having our first live session of this afternoon, the last live session, and afterwards we are going to combine it automatically with the special event and the end of the second day. Good, so in the first and second session we showed you how to do the print of this fantastic compliant mechanism. We showed you how a live selective laser printer actually looks like. Yes. So you see that this part is now really sintering live still. It will take a few more hours to get this done. And we promised you to do the live depowdering of this selective laser sinter part. So let me accompany you again to my colleague Dario, which birthday we celebrated before. Good. So Dario is basically now live depowdering this selective laser sinter powder cake. So maybe you can come a bit closer. Good. So you see that this part.
Maybe hold it next to it.
Yes, this compliant mechanism is basically now being depowdered. And afterwards I will attach it on my personal bike to test it for you guys. Good, so Dario, tell us a bit about the depowdering process. Is it difficult? Is it hard to do? Is it complicated?
No, you generally remove the big amount of powder very easily. And then after you can brush away the powder, or you can use a scraper tool and scrape it away.
Yes, good. So basically you remove the big amount of powder first. So the rough amount of powder, then inside of this powder cake we had some sliders for our Sintratec S2 starter cells as well. And then you easily can just brush apart or away the rest of the material which is not sintered. This material again can be reused with a refresh or mix ratio of 70% used material and 30% of virgin material. Is that correct, Dario? And you see that it's not a very messy process, it's not very powdery. You can easily just take your time and do that. It takes approximately, what do you mean?
Yeah, it depends on the part. A part like this is very quick. If you have like 500 of these small parts, it will take a bit longer, obviously.
Good.
But still, it's
good. So we are now basically very slowly doing this, that you can interact and see this. So please ask us questions in the chat if you have some. We have a fantastic workflow with you as well on our Sintratec.com website. And yeah, you see this is really live, how we do it, a bit slowed down, that you can enjoy this process as well and ask questions if you have some. So the rest powder goes away, and you will see that this fantastically designed compliant mechanism bottle holder from our dear colleague Stephan Henrich is basically now being created. So you see the mechanism is working.
I don't see it right now, but yes, because I'm on focus on the back side.
Oh, okay, excuse me. So can you focus on this one?
Yeah.
Good, so this compliant mechanism, this bottle holder will be afterwards attached on my personal bike, and I will enjoy the drive home then. Good.
Can you maybe explain, do you need protective eyewear to clean this, or is this
yes, so,
powder not coming in your eyes?
Yes, so I'm standing beside an official Sintratec certified service engineer. You see that he's not wearing any gloves to protect his eyes, because the powder is going to be sucked away or on the back of the machine with these 8 different ventilation zones where we have high-tech ventilation systems sucking the powder away. The rest is being sucked up by this anti-static vacuum cleaning solution. So this is how we operate on a daily basis. These systems, they are really in operation, yeah.
Maybe also explain the nozzles we have there.
Yeah, you see on the top of this vacuum cleaner we have a specific or special nozzle, which was designed by our own engineers. So thank you very much, Stephan, also for that. This nozzle works like a preliminary filter. It keeps the small parts away if you have very, very small parts to be sucked into the system. And yeah, you see, this baby pretends the smaller parts to be sucked away. Good, was a good laptop. All right, so you see the smaller sections where we maybe do not reach in with a brush. We use this, what's called, Dario?
A little scraper.
Yeah, this little scraper, you know, to remove the enclosed powder, because again, it's a powder-based process. So the entire part is lying in Sintratec TA12 powder in this specific case. And of course, we have to remove it to make sure that it works properly.
Can you maybe tell us a bit about the post-processing you could do with this now, or what's the next step?
Sure, I mean, after this process...
Repeat the question for people listening.
Sure, so the question from the audience was, is there any post-processing we need to do or that we usually do on these parts? Yes, after this process, the semi-automatic hand cleaning was done. We usually sandblast these parts with our own Sintratec blasting station. And if we would like to create a smoother and more shiny surface, we are using the Sintratec blasting station to create this nice touchy finish, this nice touchy look. I'll give you an example now. Or I'm just going to be back. Good, so I hope it's possible to see it visually. So this is a part that was blasted in the Sintratec blasting station for a longer time. And this one was just blasted for about, 1, 2, 3, 4 minutes. So you can easily see, may I? That this is how it looks roughly. And this is after blasting and polishing the parts. Is that okay, Janek? You have your focus? Good? Good, so Dario is now continuing and finishing the process. In the meantime, maybe let me show or present you or answer the question about how many parts basically fit into a Sintratec print cylinder. So we go now to this demonstrational machine. And what you see here, this is a typical Sintratec S2 print. So it's about 360 millimeters of height. It's about 130 millimeters in the diameter. And the question was about how many parts basically fit into the S2 system, into one material core. So are you in focus, Janek? Good, so please see how many small parts basically do fit in one of these print cylinders. So if you may come closer. So if this is not industrial production, then I do not know what the explanation or the definition of it is. So you see a huge amount of small parts are basically fitting into one of these Sintratec S2 print cylinders. Good, so did I answer the question, Vanessa? Good. Are there any other questions? Okay. Go maybe again. The peripherals you usually need: Sintratec blasting station, Sintratec polishing station, and then you get this fantastic, nice and shiny surface finish to make sure that your parts look basically the best. Good. So let me accompany you and go back to Dario. Dario. Good. So I think the process so far was finished then. Anything special you would like to tell our audience about what you should take care of if you depowder these parts?
Yeah, obviously if you have very thin parts, very delicate parts like the dinosaur skeleton we showed before, you need to be a bit careful to not break it, but normally with engineering parts like this, you can force it with the brush. It's strong enough, nothing will break. And then now this is cleaned for sandblasting. Obviously if you don't want to sandblast, you would clean it nicer than this. But normally we would go sandblasting in this.
Okay. Yes, so basically this is the part we sandblast afterwards. this is how the finish looks like. Maybe again, you zoom on. If you put it into the Sintratec polishing station.
Yeah,
and I think, and I think this is all that we can say to this process. So we showed you today print preparation. We showed you today live selective laser sintering. We showed you today the sieving and the mixing process and the depowdering of the parts. So this is the entire cycle that the Sintratec S2 starter cell is basically doing for you. It's a fantastic system made out again of 3 high-tech machines produced in Switzerland, the laser sintering station, the material core unit and the material handling station. It's the perfect application enabler really to dig into the technology and extend your production according to your production capabilities or needs. Good. So Dario will assist me now because this compliant mechanism, this bottle holder, he will now kindly assemble to my personal bike. And then I will present you the mechanism itself and I will have my ride back home on my bicycle. Exactly. In the meantime, let me give you a short outlook about what you can expect tomorrow from us. So tomorrow is the final live presentation day in our Sintratec headquarters in Bruck, Switzerland. We will have, again, live print preparation, live printing, and live depowdering. Tomorrow, from a part where we are going to make fantastic and thrilling action-loaded tensile strength tests. So we will go into a Swiss certified fitness center to check out how strong our parts are. Then we will go for you guys onto a construction crane to check out how strong the PA12 parts of Sintratec are. And we will have our R&D engineer Stephan talking about surfaces, so about different surface qualities that you can easily sinter or create. This is a new approach that we have been basically following to make sure that you do not just have standard parts, that you can easily change the surface as well. So it's worth to dig in. We have a talk with one of our partners from the United States of America about how the situation in the States is and how they are using our selective laser sintering systems these days. And this was basically the end of day number 2. So I'm now allowed.
Let's see on the bike how it looks.
Yes, please. Good.
Take it out here.
Thank you, Dario. Good. So you see here, this is the compliant mechanism. This is the bottle holder. This is what we printed live before. This is exactly this mechanism. And it is basically...
Wait, can you do it again? Sorry.
Yes, sure. And it's basically enclosing the bottle holder on my mountain bike.
Maybe put it in again, so...
Sure.
Close up.
Sure.
All right, looks good.
Good. So
there's no questions, I think.
Yeah, I think we covered and answered all of the questions. So thank you very much for all of you guys who tuned in and enjoyed this live presentation this afternoon. Stay tuned for tomorrow. We will have again a fantastic event that I already promoted before. My job is now done. Thanks, special thanks to the entire Sintratec team. Alessandro, wave your hand. Dario, say goodbye, and I will now take off my protective COVID-19 mask.
I want to see you right out though, into the sunset.
And we'll ride out with my fantastic mountain bike and my new compliant mechanism bottle holder for Mr. Stephan Henrich home into the fantastic, beautiful sunset of Switzerland. So goodbye and see you tomorrow, hopefully. Stay healthy. Bye-bye.
Hey.